Hey, good evening, everybody. This is Jeffrey Derose here. I'm the director of the CSI Tech Incubator, and thank you all for joining us tonight for our event for Open Data Week. And now I'd like to introduce our guest speakers. We have Thomas Abraham, the founder and CEO of HubSpire. HubSpire is actually literally one of the top software development companies in New York. And also want to say thank you to Stan, who was a regional director of AI and data research at Microsoft, for joining us, and they'll be doing a presentation today. So with that being said, I'd like to give the floor to Thomas and Stan just to give a quick introduction, and then we could, get into the presentation you guys have for us today.
So when Jeff asked me to give a presentation, I was very honored, especially because I grew up in this community. I had a lot of friends in CSI. I visited the campus many times in the past. And today, I have an opportunity, hopefully, to give you a high-level introduction to the open data. Now, this open data is a really, really vast and, probably we can talk about for months and years, right? But we're going to really focus on very high level today. When I first started my company, there weren't much incubators around. And it's a great resource. So, it's great to see that you have good participation here. And I hope, this will continue to grow. It's great to see so much interest from the community of tech innovators and entrepreneurs that are seeking to advance and grow through utilizing these platforms. So before we get started, just a little quick intro about me. I grew up in Brooklyn most of my life. I went to Temple University for my undergrad. I came back to New York. I was driving a bus for the MTA. In the night, I was going to NYU, completed my master's in technology management. And I worked for MTA for many years as an analyst. And before I left or ended my 9 to 5, I ended as the project manager at the MTA. I started my company, HubSpire, in the basement of my parents' house in Brooklyn. We started off with developing website, then went on to building mobile apps, then got into the data analytics because we were collecting a lot of data for our clients. So we realized how important that was, from data analytics to visualization. And most recently, we have added some cybersecurity line of services into our capabilities. Now we have a small office in New York City. We're located in Soho. We are a lean team, but our clients include MTA, who I used to work for. Now they're my clients, Lenovo, LG, Essex County, New Jersey. And most recently, we completed a project for Google. And we work with a lot of startups as well. And I have a feeling that, if you're here today, you're already taking the first step to becoming an entrepreneur here. Stan, I'd like to give you a couple of minutes to just give a quick introduction to yourself.
Thank you, Tom. And I also want to welcome everyone here. Definitely interesting times, but we're certainly trying to make the best of it. Like Tom, you could probably tell I was born in Texas, raised on a farm. My parents are cowboys. Absolutely not. No, I also came to this country actually 25 years ago. I went to Polytechnic University, which is now part of NYU's Staten School of Engineering. I think they change the name every 3 years, depending on who gives them money. But I think that was the latest name. I've held a variety of different IT jobs while working my way through college, from network engineering to desktop support to application development, database development. And then after college, I've had a number of different roles until I realized that I wanted to do something bigger and more challenging, and I applied at Microsoft. This was back in 2006. And still at Microsoft, 15 years later, I've had a number of different jobs at Microsoft, but currently I focus on helping our customers get the most value out of data and insights using open source technologies and Microsoft technologies. The funny thing, and you'll see that in the presentation, I've actually learned about open data during a private business endeavor, and we used open data to help us navigate the competitive landscape. And then over the years, I've learned to find valuable insights in open data, and today it's a tool in my activity with customers. We use it as examples, we use it as inspirations, we use it as technology enhancers, and hopefully you'll see some of that today. I was warned that this is not a very technical audience, but I made a bold decision to show you some technical stuff, just a little bit. We're not going to bore you. No one's going to die from looking at 3 minutes of Spark. I hope no one's going to die. I did sign a release saying that I'm not accountable for any of that. So hopefully you guys and girls will see something useful today that you can jot down on your notepad and they could do something interesting with that. I'm back to you.
All right. Thank you, Stan. All right. So we're definitely going to talk about open data. Enough about us here now, right? So the agenda is really straightforward, very simple, right? We're going to talk about open data, some little bit of definition, the strategy, some of the platforms we use, and a lot of the data community uses. Then we're going to just touch upon data, advanced data analytics for anyone who's interested in pursuing that later. Then Stan's going to have the use case and some demonstration. That's really what you want to see, so you can see how to utilize this open data. And we're going to leave a lot of time for Q&A because I think that's really important. So Stan, let's go to the next. All right. So, there are 3 principal components in any successful open data, right? On the open data ecosystem. That's the first one is the citizen, second is the government, and third is the business. The data that is available, what does it do? It creates the open data creates transparency, builds trust, stimulates innovation, and entrepreneurship. Having this public data enables social enterprise to start up anywhere, reinforcing local economies, and also enable new generation of small businesses. And in this segment, we're definitely focusing on Open Data NYC, which is all like Jeff said earlier, the Mayor's Office of Data Analytics and the Department of Information Technology and Telecommunication. They're the ones that create this open data platform and team. Okay, so what is open data? It's basically data that can be freely used, reused, and redistributed by anyone. So if you have access to it, now there are some terms, privacy policies that the NYC Open Data has, so you should definitely review it. But in general terms, it's data that you can freely use for, you can redistribute it, you can intermix with other data sets, you can also use it for commercial or educational purposes. So you can actually use this data to make money, right? There's nothing holding you back. There's no strict restrictions there. And the data sources various organization, but mainly government. Government is who really provides most of this open data. Now, where do you get this data? You can get it from government websites. GitHub. GitHub is a private company. It's a source code repository. They also have a lot of open source materials that other users like ourselves, yourself, can go and share information. And there's a ton of information you can find there. And Kaggle recently found, I recently found this company. It's a private company. It's a community of data scientists and machine learners. They have a lot of contests focused around open data for cash prizes. So if you're looking for something to do, and if you're good at what or if you like what you're doing, you can definitely look at Kaggle and get some projects. Then, this open data, right? Availability and access. Most of the time, the data is distributed as a CSV, or known as comma separated value file format, right? So once you get the data, you can download it, and then you can use from Excel to many of which I'll talk about in a few minutes. I'm gonna jump in over there. I do have some cheat notes here, so I am gonna look at my notes here, guys. So full disclosure that I have some notes here, otherwise I'll be all over the place. All right, so Stan, I think we can go to the next slide.
Absolutely. I just wanted to add to the availability and access. Most open data platforms make it available as CSV. Many of them also make it available through an API as a JSON document, so that data engineers can use Python or other data factory jobs to automatically pull and pull data. And the reason for that is that if you have a very large data set, and we'll look at some of these today, then pulling down a CSV every night isn't great, right? If you're looking at a 15, 20, 25 gig file, then downloading it daily or nightly, however often the data refreshes, is ineffective. There are use cases where it may work, and we'll look at one today, but typically you may want to retrieve the delta via an API by holding on to what's called the watermark. So you basically you store the last record or the last date when the data was retrieved, and then when you interact with an API, you only ask for data that's newer or fresher than the watermark itself. And we'll talk about some of the challenges with open data, conceptual and realistic, that will click into some of these concepts on the later slides.
Real quick, would you just mind just explaining what an API is for those who don't understand or know what that is? Just simple definition.
Sure. So it's an application programming interface, if I'm not mistaken. It's an endpoint, a programmatic endpoint, which can be invoked or called through a piece of code. So instead of downloading a CSV, you basically have a unique URL. And by calling onto that URL, you will get a payload in response with an answer. And the answer might be a JSON document or an XML document. And what makes APIs interesting is that you can actually pass parameters into those calls. So you could say, I'm calling on all of New York City motor vehicle collision data, but I'm only interested in collisions that took place between January 1st, 2021 and today, right? You're not interested in all the collisions that took place in the last 10 years because you already downloaded that through what's called incremental data loads, assuming you've been running this for a while. So, and this is probably the most simplistic way of thinking about APIs. To Tom's point, there's three types of data. There's corporate data that's guarded and protected, and it's high quality data, and a lot of effort goes into enhancing it. There is what I would call semi-open data, right? The data that you could get from Yelp or Facebook Graph API or GitHub or LinkedIn, where you have to register, and either free or for a small fee, you get access to that data. And then there is free, fully open data, which is what we're talking about today. So the open data that we're discussing today is always anonymized. There's other properties to it, but it's important to remember that it will always be anonymized, and that means that somebody has gone in. Is that how you say it in English? Gone in? It just sounds weird, but I think that's how you say it. So somebody went in and they modified it. They either sterilized it, or they've changed the granularity of the data, or they removed certain components of the data to make it de-identifiable. And we have to keep it in mind because it makes this data more challenging to work with than, let's say, if you worked at Google or Coke or Geico and you were dealing with their internal corporate data. So we'll look into those examples later on. But I know you asked me a question about APIs, but I wanted to give a more holistic answer. I hope you don't mind.
No, that was perfect. Thank you. And you can continue with the presentation. Thank you.
Awesome. And by the way, that personal identification data that Stan mentioned, right? That's really that the whole privacy policy, all these laws that are there right now. I mean, it's really important. So any of the information that you get from open data will not have anyone's name, anyone's email, phone number, or addresses. It won't have personal, anything that can identify a person by any personal identifying information. So here, right, this types of data, right? So the open data platform, the NYC Open Data, they categorize the data sets. So you have a business, you have city, you have education, environment, government, and health. And then within each of these categories, they, like police, NYPD, for example, New York Police Department, I believe they were in the city, I think they were in the city part of the data sets. And then you have 311 that was also part of the city, right? And then the health for the hospitals that provide, like COVID-19, right? Daily counts, hospitalization, and death. That was part of, and when you go into the health category, you'll find that information. More like once you are in any of these categories, I've just listed just a few samples of the data that are available: college enrollment, the 311 service request. If you're looking for rental reported violation, you can find that in there. Road and inspection details. Then, we're a minority business enterprise. So if you're looking for the MWBE's minority or women-owned business enterprise certified business, if you're looking to get a list of all the MWBs in New York, you can get that from the open data. And then there's thousands of data that's available, right? Including geographical data. So again, when we think about any of these data, if you're looking at that motor vehicle collision, you won't know that Thomas and Stan got into a car accident at this intersection, but you will know there was an accident at intersection X and Y. Okay, so that's what Stan was talking about earlier. So Stan, if you can go to the next.
Absolutely. Do you mind if I jump in?
Yeah, no, please.
So you're absolutely right. Our names are not going to be on that record, but there will be a time of day, a location, possibly a vehicle type, and additional information. We'll see that later on. But what a lot of our customers and organizations do is they pull this type of open data, and then they combine it with other sources, other data sets. So they might have their own data that they collect or purchase from another provider, or they might pull another open data set from NOAA, National Oceanographic Agency, right? That has historical weather and future weather predictions, right? So taking the motor vehicle collision for a second, right? So you got the motor vehicle collision data that shows you the intersection, so you know the zip code, or you actually know the location of that collision, and you know the time of day and the day of the year, and some additional data sets, right? So, but those two allow you to intersect with other data sets. So you can pull in historical weather information at no cost from NOAA, also open data, and then you can intersect those and you can see what was the weather when that collision took place. Was it snowing? Was it raining? Was there ice on the road, right? Was the temperature below freezing? Has the temperature been below freezing for the last 18 hours, which, preceded by rain or snow? So you could start inferring certain outcomes from that. Then you can overlay a demographics data set on top of that, also freely available. Now we're mixing NASA, federal, state, and local data sets, right? These are all open data, and we're mixing them to maybe benchmark certain areas based on demographics and time of year to see where accidents happen or where they might happen given those factors. So the data set is useful, but it becomes more useful when you start enhancing it with other relevant sets of data.
And to that point, right, many of the businesses that we speak with, whether they're corporate or government even, and small startups, they don't realize how much data that is available to them, and they need to do the research. The data is available, we're going to provide a couple of use cases, and Stan mentioned a few more right now. So there are tons of use cases that it's like almost unlimited in any business you want to do. And I have a couple of sample use cases that I'll talk about really quick in the next couple of slides. Let's go to the next slide for 1 second, please. Thank you. Here you go. So now, we talked about how to go and get this data, right? We talked about, the types of data, and there's a lot more, but there's types of data. Now, if you're starting a business, or if you're looking to provide some information to someone, right, from this open data, what is it that you really need to do? Number one, you need to know what area of interest are you interested in, right? What's the business case for you? So you need to understand the data. So that's going to take some time. Like going to NYC Open Data, you can spend days, weeks, months there looking at data. There's plenty of data there. So you need to kind of have an idea of what you're looking at. Then you need to know where the data source is coming from, what agency. Then what data is being collected. So you have to look at, a single agency may have a couple of data sets. So you may look at each of them and look to see what each of them means to you, right? Then how often is the data updated? Because this open source data is not always available, unless sometimes, like Stan earlier said, they have an API, then you have readily available data that you can probably access anytime you want. But most often, a lot of this open data, from NYC Open Data anyway, it's downloadable data. Each of these agencies, various agencies, they will upload, at a certain day of the week. I've seen some of the agencies they're doing on a daily basis, I think, or a weekly basis. So it's various. It all depends on the availability of the data, and also, like Stan said earlier, scrubbing the data before they release the data. They need to remove any of the information that's that could be identify someone. So they'll remove that data, right? And the next step is you identify the data that you need, you download it. We're going to talk about not the API version of it. We're going to be kind of talking about the downloaded data sets. So once you download the data, what is the next step, right? So Stan, anything to add to that?
No, I think you're hitting all the right points. One thing that I think is important for us to realize is that, and you have to be prepared for this. This data might make sense when you look at a single data set, but mind you that when you start looking at it holistically, you'll realize that there's going to be some limitations that need to be engineered around. Let me give you some examples. As Tom was saying, some of this data is updated daily, some is updated weekly, some is updated monthly. Okay, noted. Another thing that you'll notice is that each data set has a schema, right? A schema defines the columns or the fields in the data set, right? So if you're looking at an API, these are your elements. If you're looking at a CSV file, these are your columns. Now, the open data providers, right? So NYC 311, NYC Open Data is a portal. The agencies are responsible for making the data available. And that schema can change at any point in time, right? They can go in and say, well, we're going to drop these 5 columns and we're going to replace it with other 2 columns. So you have to be aware that you're given something that, because of the license type, can change without your consent. So that's something to be mindful of. As you start doing your data engineering, you want to keep that in the back of your head. The other challenges that you'll discover is that data quality and data consistency might change on you, right? If you worked at Apple or Coca-Cola or pick your favorite brand, I guarantee you they spend hundreds of millions of dollars a year on data governance, making sure that the data is consistent, data is clean, meaning it has high quality, it has high integrity, meaning you can run a query or a job that interconnects multiple sets of data into a holistic result. With open data, each data set is independent of every other data set. So it's up to you to find those intersection points. And sometimes you have to do a little bit of engineering to make sure that those intersection points align.
Absolutely. Stan, we can go to the next slide now. So, if we want to just highlight some of the platforms to analyze the data. Now, all these tools require training. Okay, there are courses that you can take, whether it's boot camp courses or college courses. But we use a lot of Power BI in our company. We use Tableau. We have used Google Data Studio recently. And then some of the other ones we have not used. And the NYC Open Data platform, they also have a tool where you can visualize the data, do some filtering, and to extract in the data. They have a tool. I'm not sure exactly what they're using. It looks like a pretty customized tool that they've integrated. But there are advantages. Obviously, it's free and you can kind of extract the data that you want. But like using any of these platforms here, right, to analyze the data, you can bring in all your data sets, multiple tables, and then figure out a way how to link each of these tables together, and then use your own analytics. And some of them have a lot more newer capabilities of, from asking questions, you can just simply, type or even ask a question to kind of extract some of the data very easily even for beginners. But these tools, most of them, they do have free trials, and if you're like a single user, they may have free versions, but most of them have subscriptions. You got to pay for it, right? So these are all private tools. Stan, anything to add to this?
The only thing that I would add is, and you'll see this later, there's multiple roles within this ecosystem. There's a couple of tools here, and I'll use my little laser pencil here. So these, Tom, can you see me doodling on the slide?
Yeah, I can.
Okay, so these are your business intelligence tools. Typically, they require zero coding. So you're not a developer, you're not an engineer, you're most likely just using the interface and clicking and dragging and dropping stuff. And Tom's right, some of these are available at no cost. A lot of my customers use Power BI because it's free for the desktop. So you can connect to 3 different open data sets and maybe some of your corporate or private data and build it into a holistic model. You'll see that later on. Tableau, Looker, Click, they do similar things. So red is business intelligence. Purple is data engineering, right? So now you're crossing the path into development. right? You're using Python, you're using Scala, you're using R, you're using Hive. You're writing code to get insights out of your data. Many times you have to do a little bit of both. There are other options that aren't here that will show you in the demo, but just keep in mind that there's multiple roles. And you don't have to be one person to cover every role. It's impossible. As a matter of fact, I don't have any customers that have mastered, where a single individual has mastered data analytics and data engineering, let alone data science or machine learning, which can also be done in Databricks and Apache Spark. So it's a big world, but we'll try to guide you towards the consumable boxes where it makes sense to you guys.
Right, awesome. So the next here, right, I just wanted to touch up on, like I told you earlier, it's a very vast, area, data analytics or data, or any kind of open data. So there are types of advanced data analytics, right? If you wanted to, look further into it, the vision-based models. That's like image recognition. That would be like a vision-based models. That's when, right now a lot of you see, you can go into a store, they can identify you with images and see who you are, race, color. I mean, they can do a lot of with visualization.
And most customers today deploy vision-based models at the edge, meaning it's not done in the post data collection stage somewhere in a data center 3 weeks after they've generated the image, but rather using, for instance, we have a lot of customers that use cameras, and this is COVID reality, basically a security camera that's pointed at the entrance of the facility. And they run vision-based models on that camera, meaning on the edge, on the device, to figure out if there's mask compliance. So if somebody walks into a store or a hospital or a government facility without a mask, the machine will alert either a door operator or somebody at the security desk that there's a violation of the mask policy, where they don't need to put a person at every door and make sure that everyone's wearing a mask. It's a lot cheaper to put a camera and do that vision-based analytics on the edge than pay somebody a salary to just stand there and watch.
Great example. Excellent example. So the next one is NLP, right, which is the natural language processing model. That is basically understanding almost human natural language, right? You can record a complete session, and then you can have this model analyze everything that we spoke about, who spoke about what, and have a complete analytics based on natural language. And then the third one is the predictive model. This is what, like I think Stan mentioned earlier about the weather. So if you have enough data, this does require a lot of years of data, right? And that's not, you probably can't use it with a couple of weeks worth of data. You probably need a lot of historical data, and then based on that, a lot of the application that we spoke about earlier, they can even predict the future almost. So if March had, average temperature of 40 degrees, and there's a way to predict what will happen in 2022, right? So that type of predictability.
Yeah, and to your point about traffic accidents, working with law enforcement agencies, part of their job is to reduce fatalities on the road and accidents. And if any of you guys and girls have friends that are police officers, they'll tell you that they know, they can predict stuff. They know what intersection is dangerous. They know what curve is probably going to get an accident, this month, because they've been doing the job for years and years. And that's called institutional intelligence, right? When the sergeant who's covered a certain area can predict how many accidents they're going to have on a certain turn in February, right? Because he's done it for many years. The problem is it's expensive to rely on people, and sometimes people don't make the best predictions, and people can't make massive predictions. So to Tom's point, right? Looking back at the data set of vehicle collisions, intersecting it with weather, and intersecting it with location, maybe there's a dangerous curve that when it gets a little icy, people take the curve at a higher rate of speed than would be prudent, and they go wide and they crash into the divider, right? And I think we can all think of a place like that is more prone to a car accident or a car crash than not. So the predictive model would be able to identify the likelihood of all of these locations throughout New York City. So the bureau chief for traffic division of NYPD would get a report that says, here's the 50 locations that we think has a high likelihood of experiencing a crash, ranked by the likelihood of each location, right? And then it's up to the human to decide, okay, well, I only have 10 officers, I only have 10 police cars that I can dispatch. Maybe I'll dispatch 3 cars to these 3 highest risk locations, and then I'll work with Department of Transportation to put up signage, the LED signs asking people to slow down because, reminding them that the road has ice and it's a sharp curve. It allows us to anticipate the future and react prior to something happening.
All right, great. No, go to the next slide for a second, please. And I'm going to go through some of these use cases really fast because I think, it'll start to make sense when we talk about these use cases. So obviously we all know restaurants in New York City, they do get violation notices from the Department of Health, right? And so let's assume that, you have a law firm or a law firm has hired you and you have a business that can provide some analytics. So what would you be looking for, right? So the law firm, they want to, my example is that in a law firm that wants to market, like they specialize in fighting restaurant violations. Okay. So they want to know where should they actually market their business? Like where do they want to get displayed? Where do they want to put a poster on the bus stop? Or where do they want to put their, those big signs on the roads? Where do they want to put it? So what they can do is they can go into this open data. They can get an idea of which restaurants in what areas are getting the highest violations, which borough, right? They can target a single borough. They can target a single zip code, and they can see how many violations are being have summons or violations for some of these restaurants. And then they can maybe they can now use another listing source to find the businesses' addresses. They won't know which business got the violation, but they will know, this area, 30% of the businesses get violations. So what they can do is they can send, flyers or mail pamphlets to every single restaurant based on the data from the open data. Now, the second, my example here is, let's say, for example, somebody here wants to, start a online tutoring company or a tutoring business, right? So when I looked through the open data, I found information regarding test results for math test results, SAT test results, graduation outcomes, school progress report, and there's a lot more that the education, if you go to the category education, you'll find all of this information. And now you can kind of combine these data, right, interlink them and find out, okay, if I was going to start a tutoring business, where would I start, right? And then if you want to look at this, there's actually some new data about remote learning, so school attendance. That was another data set that you can bring in. Now, if you wanted to target those parents that you feel in areas that are the kids are not doing great in math, right? You can start to advertise to them. You can open up your business in that area. You can open up multiple locations. So these are just some really simple use cases that I spoke about here. I think, Stan, I'll turn it over to you now to kind of give us a full visual and an idea on how to use this data.
Thank you. No, and these are great examples. And I want to give a shout out to New York City MODA, Mayor's Department of Data Analytics, who manage the open data portal. So looking at the violation notices, New York City actually makes the data available with a very high degree of granularity. So they'll share the restaurant name, the restaurant location. Obviously, they won't share the owner's name because that's PII. We all know what PII is, right? But the business itself is a registered entity. Other government entities may not share as much, but MODA certainly does a phenomenal job at that. And talking about restaurants, I want to share a little story. So back in 2010, I was given an opportunity to become an owner in a little pizzeria joint in Brooklyn Heights. This is the downtown area next to Court Street. I don't know if anyone's familiar with Ramson Street. Court Street, that whole area. And my partner and I, I worked at Microsoft at the time, and I did this on the weekends and at nights. I managed everything related to marketing, advertising, relationships with online delivery services, photography, sales, data analytics, and he was responsible for running the whole store. So he took a leave of absence from Brooklyn Law School to start this business. And I'm a Microsoft data guy at the time, so you can